All right, so section 2.7 is called curve fitting with linear models, which sounds really weird. Curve fitting with linear models. You see the word curve and then the word line. But what we're doing here, basically the gist of this lesson is, this whole chapter, well, part of this chapter has been how do we create an equation, right? Given all sorts of things, how do we create an equation? Given 2 points, given a point and a slope, given a perpendicular line, given a parallel line, how do we create an equation? So we're just going to extend upon that here. But now what we're going to do is say, okay, what if you've got real life data? What if you've got real life data? How do you create an equation on real life data? How do you create an equation based on a real world situation that is not just like, oh, I've got, I need to make $155 and I spent $120 and I got selling $6 a ticket, not that kind of real life situation. I'm talking like you've taken statistics, right? You've taken reading. You've taken readings, or you've taken observations of things, and you're saying, okay, what can I tell about what I've seen? That's what we're working with here. I can input information into our calculator, and it will generate for me an equation. Okay. All right. So curve fitting with linear models. The first thing we have to talk about is scatter plots. Now, scatter plots is a very simple idea. I'm only ever going to do one on the next, maybe 2 slides away. But scatter plots are basically just taking the data and putting it on a graph. And the hope is that you see some sort of trend. Okay, the hope is that you see some sort of trend, some sort of correlation. Okay, scatter plots are helpful in understanding the form, direction, and strength of the relationship between two variables. The word correlation is the strength and direction of the linear relationship. Strength and direction, how well two things correlate. Think about the word correlate, right? They go together. How well two things correlate is how closely they are tied together. Now, it doesn't mean cause. The word cause and correlate are very different, right? Maybe you would be able to find correlations between two different things, but does that mean they cause each other? No, not necessarily. Like, that's what, there's so many times I always hear like, oh, it's always these random things like, oh, a couple years back, like, oh, tomatoes cause cancer now. It's like every time something new, oh, that causes cancer now. They find statistics, they run statistics, and then they say, oh, there might be a correlation. But does that mean that caused anything to happen? Not necessarily. Not necessarily. You need a lot of statistics to determine causation. You need more science to determine causation. The math piece is about the correlation. Okay? Maybe they go together, but what outside factors made them go together? Okay, so correlation, the different types of correlation that we can have. This is positive correlation. Obviously, you see a positive sloping line. Negative correlation, you see the negative sloping line. And then relatively no correlation at all, you see over there. It's all about the slope of the line. Okay, it's all about the slope of the line. The closer those points fit toward an actual line, the better you see a trend, the higher the strength of the correlation. Okay, the higher the strength of the correlation. Now, how do we define what that is? How do we numerically define what that is? Well, then we talk about what's called the correlation coefficient. The correlation coefficient is what we're going to call the R value. It's a number that our calculator will spit out to us. You can find the actual R value. If you take statistics courses in college, you will actually have to do all of this without your calculator, do it by hand and know the formulas to do such things. But for right now, we're just going to rely on our calculator pretty heavily. But the correlation coefficient R is a measure of how well the data set is fit by a given model. Now, this word model, the model just basically means the equation that the calculator spits out for us. How strongly does it fit a particular line? That's going to be the R value. How strongly does it fit to that to that equation. How closely do those points line up actually on a line? That's the R value. The better the R value, the stronger the correlation. Doesn't mean a cause, but the stronger the correlation. Okay, the weaker the R value, the weaker the correlation, obviously. Now, what does that mean? What is that strong versus weak? What does that mean in terms of the R value? Okay, so talking about an R value, the R value is a number that will range between -1 to +1. Okay, R values always range between -1, +1. The further you get toward 1, the stronger the correlation in the positive direction. Okay, the closer you get toward 1, the stronger the correlation in the positive direction. The closer you get toward -1, the stronger the correlation in the negative direction. The closer you get toward 0, the weaker the correlation. Okay, so if you're starting at +1, strongest correlation you could possibly get. I get closer and closer and closer to 0, the correlation becomes more scattered. Less likely you would see any sort of trend. The closer you get toward 0, less likely to see a trend. The closer you get toward -1, the stronger and stronger the correlation gets, but in the negative direction rather than the positive direction. And you see here some examples of such. Here's a negative correlated line. Okay, so this would be like an R value around like -0.95. It has to be like perfectly on the line to be a -1 or +1. This would be around a 0.6. I see somewhat of a downward sloping trend, but where would I draw the line? Would I draw my line in here, or would I draw it in here? Would I draw it in here? Not really sure, right? This relatively no correlation. I can't, is it going up? Is it going down? I don't know. Here I see a general upward sloping trend, but not really. Where's my line? Is it anywhere in there? Is it there? I'm not really sure. This is a better correlation here. This 0.95. I know exactly where to put my line. Okay. So this is what's called our correlation coefficient. This is a number that the calculator will spit out to you, but you have to know how to interpret that number. We can use a graphing calculator to perform what's called a linear regression and find the correlation coefficient. Okay, so this is where it's going to start to get fun. Let's start by opening up our calculators and turning on our diagnostics. Turning on what's called our diagnostics. Let me get that out of there. Excuse me. Okay. Now, how do we do that? Well, we have to go hit second 0. Second, and then you see how above 0 it says catalog? That is the catalog of every function that your calculator does. So I'm going to go a catalog here. There's no other place to find it, so we just got to go down to D. Or if you hit the D button, like the matrix next to the inverse button, the D in the green, that D button, it will jump you down to the Ds. But scroll down to diagnostics on. There we go. You hit it once. Now, whenever you select a program, it's going to bring it to the home screen. Then you have to run that program. Okay, now my diagnostics are on. Now, why did we do that? Well, because your calculator is not preset to run your diagnostics. Okay, the diagnostics are the R value, strength. Okay, I don't know why it's not preset. I wish it was. I don't know. But if you ever reset your calculator, if your calculator ever goes dead, generally it clears your memory. So therefore, you might have to do that again. That's one of those things, like if you come up to me during a quiz or test and you're like, I don't know how to turn my R value on, I'll be like, oh, give me your calculator, I'll do it for you. And I'll just do it real quick, because that's not something I'm going to expect you to know how to do like that. Okay. All right, so let's go here. This is the table on the back of your graph, or on the back of your guided data. This is the table on the back of your guided data. Let's kind of analyze what's happening here before we start doing anything, before we start to even play with our calculators a little bit. We say that Albany and Sydney are about the same distance from the equator. Make a scatter. Now mine says make a scatter plot. Did you say make a scatter plot? Yeah. Mine says make a scatter plot with Albany's temperatures as the independent variable. Name the type of correlation, then sketch a line of best fit and find its equation. Okay, now think about it's always good to think about what type of trend you think you would see. Okay, let's talk about it. Sydney, Australia, in the southern hemisphere, right? Albany, New York, in the northern hemisphere, probably about the same distance away from the equator, right? Probably about the same distance away from the equator. So what's going on in December in New York? Is it really hot or really cold? Cold. What about Sydney, Australia? Hot, right? And then those are inversely proportional, right? As one gets warmer, the other one gets cooler. And as the other one gets cooler, the other one gets warmer, right? So as I increase my temperatures for Albany, what should happen with my temperatures for Sydney? They should go down, right? I should see, I should see some sort of negatively sloping trend. And I bet it's probably a strong correlation too. You know, weather and things like that, you know, kind of are you know, more strongly correlated. But like these temperature things, I mean, that's pretty even. That's pretty, I mean, there will be some variation here or there depending on the weather for certain days. But these are average temperatures within a month, aren't they? Yeah, average temperature within a month. So we're taking average of 30 values. So generally, it's going to give us a good reading here. Now, it says to make a scatter plot. I don't know. I hesitate to even actually make this scatter plot with you. We would all be able to make a scatter plot, right? I mean, just plot the points, right? January is 3165. So I would go 31, 65. And I would put my dot there. And guess what? Here's your scatter plot for you. Hey, and we see some sort of negatively sloping trend. The reason I'm kind of so, you know, flippant about that is that let's do this on our calculators. There's an easier way to do this. Let me show you how to do this on your calculator. Now, Mrs. Naples 1 year was very, very nice. And she put a screenshot by screenshot worksheet together for you guys. Yes, everybody turn and say, thank you, Mrs. Naples.
Thank you, Mrs. Naples.
And she put a screenshot by screenshot direction worksheet for you guys. Don't lose this. I posted this on today's notes, this document. So if you ever need one again, you could go and print it out. But I will tell you this. These are the same directions that I will ask you to pull out in April when we're doing these regressions over and over again. Because what we're going to do right now is I'm going to make a scatter plot and we're going to draw the line of best fit, but your calculator actually runs the calculations it needs to find the exact equation of the line of best fit. Later on, we're going to look at statistics that don't look like a line. They look like a curve. They look maybe like a quadratic. And then your calculator is going to be nice enough for you, and it's going to run the equation to show you what quadratic fits that data. We're going to do the same thing for polynomial. We're going to do the same thing for exponential. We could probably do the same thing for all different types of functions that we learned. But the directions still remain the same. So this is a very important sheet of paper that I'm going to hand out to you. Please don't lose this. Mrs. Apples made hers like purple or something, which that was a good idea. I should have made it like a weird color so I could say like, oh, get out that purple sheet. But at any rate, this document is on Canvas, and it's located in today's notes. I made some extra copies, so I'm going to keep some like in the cubbies over there, because this is something that you'll want to have readily available. This is not something that I would ever let you use on a quiz or test, however. This is just a reference sheet for you guys to refer back to when you're taking your quiz, or not, when you're doing your homework, or when you're, when we're doing our notes or something. Okay, so it says, make a scatter plot. I'm going to show you how to make a scatter plot in your calculators. So the first thing that we have to do is we have to enter in our data. We have to enter in our data. How do we do that? You see that statistics button? Okay. You hit stat and then edit. Stat, and then you're going to choose the first choice, edit. Now it kind of brings up this spreadsheet type looking thing. Yours looks like a little bit more like of an Excel sheet. Yeah? Well, for those of you who have a little bit newer calculators. Mine just looks like I'm putting in two tables, which is kind of like the same thing. So what we have to do is, if you've got information already in there, you go up to L1, list 1, and you hit clear, and then you push the down arrow, and that will clear everything from that list. So like when we're going to do this again, you're going to have data already in there. You just scroll up to list 2, you hit the clear button, don't hit delete. You will delete that list, and then you'll have to go back and like reset some things. But you hit clear, and then you go down. Okay. If you ever get lost and you're like, whoa, 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 I'm not on that screen, this is a day where I will have to like help you guys along. So like if you're like, whoa, I lost it there. Yeah. We good? Anybody? We good? Yeah.
I don't know what I do. I'm like,
Let me see. Oh, you're good. You're good.
right?
Yeah. Yeah. Now yours like looks like mine, right?
Yeah.
Yeah. Yeah, you're good. Yeah.
Should I be concerned about the fact that mine says L2?
Yeah, so someone must have deleted. Can you hit the left button? It's not just hiding over there, is it?
No, it's
Nope.
not.
Okay, so if you ever delete a list, let me show this, because this is for Anna. But if you ever delete a list, like look up here, I can do this, boop, and guess what? It's gone. If I accidentally hit the delete key when up on L1, you just have to go stat, hit stat for me, and then see choice 5, setup editor. Just hit that and run it, and now it's back. Stat, edit, and now list 1 is back. Is it back now? No?
Maybe I did it.
Hold on. Let me see it. Yeah, hit it. Hit enter one more time. Yeah, you got to run the program, right? All right, so now I'm ready to enter my data. So please, everybody, let's enter in. You see it on your papers. Let's hit enter in Albany as list 1 and Sydney as list 2. Everything must go in order. These are ordered pairs. 31 must be right next to 65 and so on, right? Everything must be in order exactly as you see it. And I'm going to take a moment here and enter it in with my keypad. You should have 12 pieces of data. And I see how many it is because look, this is L2 and then in parentheses it says 12. That means that's my 12th piece of data in list 2. Okay, do we have our data entered? Mostly. Okay, so the next step is going to let the calculator plot those points. It's going to connect every x value to every y value. Okay. All right, so everybody hit your y equals button. Now I've got junk in there right now, right? I've got equations in there. I'm going to hit the clear button to get those out of there, clear everything out. And do you guys see plot 1, plot 2, plot 3 up above? I'm going to turn on plot 1. I'm going to go up to plot 1 and I'm going to hit enter on it. and it's gonna make it dark. Now, the other way to do that is if you hit second, you see stat plot above the y equals? If you hit stat plot up there, oh, come on, second y equals, there you go. If you hit stat plot, look, plot 1 is on, right? Plot 1 is on. I hit enter into plot 1, and you could do different things. You can turn it on and off. You can change the type of graph that it's going to give you. Like for some reason, it looks like I wanted to do a box and whisker plot at some point along the way. So I'm just going to hit it back on a scatter plot. You can do a bar graph, you can do a line graph, you can do whatever. And then it's saying, okay, what do you want for your first values? List 1. What do you want for your second values? List 2. And what kind of marks do you want to make on the screen? Well, we'll just choose those little squares, right? Okay, so my plot 1 is on now, right? My plot 1 is on. And we just simply did that just by highlighting plot 1, just darkening plot 1, turning on plot 1 from our y equals page. Now, you see this zoom button in the middle? Click that, and then if you scroll down, please, until you see zoom stat. Zoom, oh, I went too far. Whoa, I went way too far. Right in the middle, up the top row. There we go, zoom stat. For me, it's zoom 9. Does it say for you guys, zoom 9? Yeah. Zoom 9. And I hit enter on that, and there's my scatter plot. So from here on out, if it says to make a scatter plot, you can do it in your calculators. Just make sure that you sketch what you see in your homework, okay? I will never ask you to make a scatter plot on your quiz text. Yes? Has an error. What's the error say? Invalid dimensions. Go back to stat and edit and clear that. Hit stat here, and then hit enter on edit. You've got list 2 list 3. Now, for our sake and purposes right now, I'm going to do this. And I'm going to make it go to list 2 and list 3. Yeah, I would make you have to put that all in again. 2. Oh, shit, it's in that. There we go. You need to run that setup editor thing later on. All done? Okay. All right. Okay, so now I've got my scatter plot, right? Now, it then says to make the line of best fit, right? Make the line of best fit. Find the line of best fit and its equation. Now, to do that, we need to run what's called a linear regression. The actual process of this is actually really cool. I remember doing this. I just had to do it rather recently, where it basically finds the averages of all the x values and the average of all the y values, and basically makes the slope off of those average x and average y. And then it just calculates the error away from each one, and that's how it connects. That's how it does the line. It's actually kind of cool. But what your calculator can do here, we go back out to the home screen by hitting second quit, and you just go stat. And now, right where we went to go edit our lists, if you scroll right to calc, stats right here, and then if you scroll right to calc, scroll right one arrow to calc, you see down here, choice 4 is linear regression, linreg. You click down here on choice 4, linreg, and then you run it. Now, some of you guys have different options. You might have to scroll down to hit calculate, and you might have to actually change yours to list 2, list 3. How did you do it, Eric? Oh, awesome. Okay, second quit. Yeah. Now stat. Scroll right once to calc, and then choice 4, linreg. And then hit enter. And then you're going to have to go down to calculate and enter. See, my calculator just runs it. I don't have to worry about that. Yeah. Here it is. You see what's on my screen? Does my screen match your screen? Check the numbers on my screen. Now, this is telling me the equation. This is actually telling me the equation. Let's take a look at it. How is it telling me the equation? Well, oops, that's an error. Look at the form. Y is equal to ax plus b. What is that form? Slope-intercept, where a is the slope, right? It tells me my a and b value. My slope, my a value is negative 0.4638. Y equals negative 0.4638. I always like to go out to 4 decimal places when doing this process, but it all depends. Plus 80.0845. And that's the equation of the line of best fit. Now, how do I make that line show up? Now, hold please. Look at what I have. What's my R value? Negative, which makes sense. We had a negatively correlating line. Negative 0.98. Super strong, right? That's a very strong correlation. Awesome. Negative, excuse me, negative 0.98. Don't worry about R squared right now. We'll talk about that a little bit later on. Promise. When we get to like quadratics and stuff. If those R values are not showing up, that's when you have to go like back and do that diagnostic thing that we talked about at the beginning of class. All right. Whoops. Name the type of correlation. We got negative correlation. Find the average minimum temperature in Albany when Sydney is 50. Find the average minimum temperature in Albany when the temperature in Sydney is 50. Now, to answer questions about it, it's great that we can find this equation, but, can I predict things? Can I predict what's going to happen at certain values? That's the really cool part about this stuff, in my opinion. This is the really cool stuff. It's great to see the data, but it's even cooler to say, okay, based on this data, here's what I think is going to happen. Man, if you can predict the future, companies will pay you a lot of money. Yeah. So what I mean here is that I am going to actually put this equation on my graph now and let the graph do the talk. Okay, so I've got to go into my equals. Everybody hit your y equals. I'm going to put that equation in there. Now, I don't want you typing it in. Why? Because this is rounded. I don't want it rounded. I want exact values. Okay? So what I want to do, yes, just hit your y equals. You're good. And yeah, again, if there's ever a moment where you're like, whoa, where'd you get that screen? So I have to start in y equals with this. And I am on the top of the back of this worksheet now. Okay? I am going to input my regression onto my graph. Now to do that, I click the VARS button. It's diagonally down and to the right from staff. The VARS button. VARS stands for variable statistics. I click VARS, and now I scroll down to choice 5, which is statistics. And I go right. Did I lose you? Were you on VARS? We had y equals, then click VARS. Did you go down to statistics? And now I'm going to scroll right twice to EQ to find regression equation, reg EQ. I click enter on that, and it inputs my entire regression equation into the y equals. Okay? Now, it may seem like, well, I could have just punched in all of those numbers. Yes, that's very true. But guess what? When we get to ones that are like yay big, you don't want to punch in all those numbers. Trust me, you're going to want to just hit VARS, stat, EQ. Okay, now hit graph. And we see the line of best fit coming through our coordinates now. Okay, so we have to now interpret, okay, it says find the average minimum temperature in Albany when Sydney is 50. Okay, did I give you an X value or did I give you a Y value with Sydney being 50? Is Sydney the X values or the Y values? Sydney was the Y values, right? It was the second set of data, so it was the Y values. So what I have to do now is I'm giving you a Y value and asking you to find an X value. Find the average minimum temperature in Albany, find the X value when the Y value is 50. To do that, I have to go back into my Y equals. This is actually the if you know Y are trying to find X. The fourth bullet point down. We know Y. Y is 50. So you go into Y equals, and you have to hit 50 for your Y2. That's so crazy. This is the exact example that she made these screenshots from. I hit graph now, and it's going to give me a horizontal line running through at 50. Guess where I can find the matching X values? The intersection point. But how do we find the intersection point? Well, we can calculate the intersection point. Do you see right above the trace button up top there in that top row again? It says calc. So we hit second, and then the trace button, which is calc, and look at choice 5, intersect. The calculator will actually calculate the intersection for you. Once we get to chapter 3, we can do this algebraically. But for right now, we'll just rely on our calculators. Now it's going to ask you 3 questions. It's going to ask you first curve, second curve, and then a guess. Because potentially, we could have 3, 4, 5, 6 equations on the same graph. So it wants to know specifically, what 2 curves do you want to find the intersection point of? Guess what? We've only got 2. So we're just going to hit enter on where it says first curve, enter on where it says second curve. And now it wants a guess. Again, your calculator is a very dumb, smart object. All it does is just run values until it finds ones that matches. So it just needs a starting place. And there it is. I hit enter someplace on guess. And there we have it. The X value is 64.85. 64.85. Or 64.86. I'll put this over there. That again. So we say when it was Sydney, when Sydney is 50 degrees, Albany is 64.86 degrees. Now, is this causing these things to happen? No, this is our correlation between these 2 things. Okay. Let's continue on to our next question. Find the average minimum temperature in Sydney when Albany is 45. Okay, did I give you an X value or did I give you a Y value? I gave you an X value. This is the easier of the 2 options. If I give you an X value, life is actually pretty good. Go back to your graph, and you just hit second, calculate, and look at choice 1, value. Value of the X value is 45. Again, that was second calculate, second trace, and then the first option. And then you just enter in 45. And look at that, it's tracing it right along that diagonal line too, and it's showing you where it is on the graph. So when the X value is 45, the Y value is 59.2. Yes? Yeah. Second, calculate, and then value of 45. And then you have to hit enter right at that point. It should give you 59.21. So what does that mean? That means that the temperature in Sydney is 59 degrees when the temperature in Albany is 45 degrees. If I wanted to find the average minimum temperature in Sydney when Albany's is 75 degrees, okay, is the temperature again in Albany, is Albany 50, or sorry, is it X or Y? It's an X. So I'm going to do this whole just second calculate thing. Second calculate the value of 75 now. Now, what happened when you calculate the value of 75? Uh-oh. Gave us an error. Invalid. You know what it means? 75 doesn't show up on my screen. Okay. 75 doesn't show up on my screen. Well, let's just zoom out. Zoom. Oh, I got to clear that. I hit zoom and look at choice 3. Zoom out. Now, whenever you zoom out, you have to pick a center point. See this blinking dot? It's waiting for me to say, okay, where do you want to center your screen? If I hit enter, okay, now it zooms out. People always get stuck on that. They're like, I hit zoom out, it's not doing it. I hit zoom out, it's not doing anything. And then I say, hit enter. No. Oh, okay. So there's our screen now. We just zoomed out. Now if I run 75, if I calculate the value of 75, now it finds it. So when Albany is 75 degrees, what's the temperature in Sydney? 45.3 degrees. Okay. We will do the second example from this guided notes. We'll do that on Tuesday. That'll be a good refresher. People, you will have to rely heavily on that. That's okay. Do your homework. Do your homework with this sheet right next to you. Because I'll tell you this, once we get to the test, you won't have this sheet. You're going to need to know how to do that. Okay? You've got to practice. You have to practice. You have to practice. Shout out, Alex. Shout out.